So today the first thing that we're going to do is discuss the molar mass of gases using the ideal gas law. So let's refresh our memory on what the ideal gas law is. So ideal gas law is P V equals N, wow, nRT. Okay, now molar mass, remember, molar mass's units are grams per mole. Those are the units for molar mass. And molar masses are things that we like get off the periodic table. Like hydrogen's molar mass is 1.01 grams per mole. Carbon's molar mass is 12.01 grams per mole. So grams is a measurement for mass. Mole in this chapter has been represented by the letter N, and this equals big capital M molar mass. So if you rearrange it, you could solve for moles. So the moles would come up here and the molar mass would come down here. So rearranged algebraically, moles is mass over molar mass. This is just algebraically rearranged down here, okay? So what you can do is, if you know that moles equals mass over molar mass, well, why does that equal that? Let's look at units, okay? Mass is measured in grams divided by molar mass's units are grams per mole. So look at the grams cancel and you're left with moles. That's why this moles equals mass over molar mass. That's how that works out. So what you can do is you can have the ideal gas law in terms of mass and molar mass instead of moles. Meaning, instead of plugging the moles in right here, you take and you say, well, moles is actually also the same as saying this, mass over molar mass, and you put that in here in the place of moles. So, rewritten, I'll rewrite it again. PV equals nRT. This is the ideal gas law, where moles equals mass over big capital M means molar mass. And so rewritten, it looks like this. So instead of N right here, I have mass over molar mass, RT. This is just a rewritten version of the ideal gas law with mass and molar mass in it instead of moles. Okay? So you do not need to memorize the formulas, but you do need to know how to use them. So like, for example, this one right here, I will not give you. However, I will give you this, and I will give you this, and you should be able to rearrange it, okay? So you should be able to get from here to here with both of these given. So no, you don't need to memorize all of the equations, but you need to know how to use them, okay? So let's try a problem. It says, so again, you can substitute the moles, the mass over molar mass, in place of moles to get the new equation. So we're going to practice this a couple of times. So this says determine the molar mass, okay, of an unknown gas. So gas means I have some sort of gas law, okay? And I give you a mass in grams and a volume and a temperature and a pressure, all right? Combined gas law, the P1V1 over N1T1 equals P2V2 over N2T2 would not help us right now. We don't have like two pressures or two temperatures or two volumes. We only have one pressure, one volume, one temperature. So likely this is going to be PV equals nRT. This is the ideal gas law. Okay, but I didn't leave a space for room, so I'll do this on here. So let's retry this. You have these two equations now. This is the ideal gas law, and then you have this new one that we just learned, that moles is the same thing as mass over molar mass. And you go, okay, this problem does have a mass in it, and it is asking for molar mass. So I'm going to use this term in place of moles and my gas law to help me solve for molar mass. So I'm just going to rewrite it now. PV equals, now this whole thing replaces the moles. So now I have mass over molar mass, RT. And then what are we trying to solve for? Well, this problem is asking you for molar mass. So molar mass is in the bottom right now. I don't want it in the bottom, so I'll multiply both sides by molar mass. Okay? So now molar mass is gone, right? And then I want to get the molar mass by itself. That's the whole point because that's what I'm solving for. So I'm going to divide both sides by PV. All right? And this gives me molar mass by itself. So now this is just plug and chug. You have mass. You can go look up the gas law constant R. You have temperature, you have pressure, you have volume. You just need to plug everything in. So let's do it. So the mass from the problem was 0.290 grams. Okay. The R constant, you want to match the pressure. So the pressure is in kilopascals. So you want to use the one for kilopascals. I'm not sure. I don't know. Let me see if I gave you one. Let's look. I gave you a bunch of the R constants. Oh yeah, here it is. 8.314 liter kilopascals. This is the one for kilopascals. .314 liter kilopascal over mole Kelvin. And now temperature has to be in Kelvin. I don't think they gave you temperature in Kelvin. They gave you 13 degrees Celsius. So how do you get to Kelvin? You add 273, right? So 13 plus 273 is 286. It's done down here for you at the bottom. Okay, divided by pressure. The pressure given was 107 kilopascals. And the volume. Now, this is something we haven't encountered yet. The volume for the ideal gas law has to be in liters. It cannot be in milliliters. It can for the combined gas law because you have volume on both sides. But in the ideal gas law, the R constant's volume is liters. So your volume has to be in liters. If you don't remember, there are 1,000 milliliters in 1 liter. So 148 milliliters is the same thing as 0.148 liters. 0.148 liters. Now, let's look at the how the units cancel. So look at kilopascals on the top, kilopascals on the bottom. Liters on the top, liters on the bottom. Kelvin up here, and then Kelvin down here. And then look at, we're left with grams divided by moles. Grams per mole. That is, or are, this is the units for molar mass. Now in your calculator, because you have two things in the denominator, I highly suggest that you multiply the top out. So you do 0.290 times 8.314 times 286 and then divide by 107 and then hit the divide again by 0.148. So you hit your divide button twice. So I'll give you a second to try to calculate that out, please. I don't have my calculator handy. I guess I could use my phone. What did you guys get for this one? I got 43.5 grams per mole. So that is the molar mass of whoever this gas is. Now, there's actually, for this problem, another way to do it. So this is one way. I'm going to show you both ways, and then it's up to you which way you would like to do it on a test. It doesn't matter to me, whatever way you feel more comfortable with, okay? So I'm going to clear this off. All right, so PV equals nRT, all right? And then we know that molar mass, sorry, we know this, right, equals mass over molar mass, which just means that molar mass is mass over mole, right? Molar mass is mass over mole. I mean, this is just a rearrangement of it. Well, the thing is if you want to find the molar mass of a gas, if you know its mass in grams, and you know its moles in moles, grams divided by moles is molar mass. So if you look at this problem, you go back and you look at the problem, you have the mass. It's 0.290 grams. So it's almost like you're halfway there. 0.290 grams divided by, I don't know how many moles I have, but, right, this is molar mass. But Pervner can get us moles if we have the pressure and the volume and the temperature. And we do. So I have the grams. If I can figure out the moles, I can put that number down here, and I take my grams and I divide by moles. Grams divided by moles is molar mass. This is an alternate way to approach this problem. Oops. Sorry, sorry. I didn't realize I was on mute. So let me just go back and repeat that. Oops. Where's my whiteboard? Oh, I closed my whiteboard, that's why. So what I was just saying is there's an alternate way to do this problem because moles is mass over molar mass. Molar mass is mass over mole. This right here is just a rearrangement of this one. So if you know grams and you know moles, if you take grams and divide by moles, you will get molar mass. Grams divided by moles is molar mass. Well, I gave you grams in the problem, so you already have grams. Here are your grams. If we can figure out moles, the bottom part, you can take your grams, this 0.290, and divide by your moles, and grams divided by moles is molar mass. Well, Pervner has moles in it. So you can use Pervner to get moles as long as you know pressure and you know volume and you know temperature and you always know R. You do not need to memorize it. You always know R. So as long as you know those, you could find moles and then plug that number in down here and solve for molar mass this way. This is just an alternate method. It does not matter which way you use. I want you guys to use the way that you feel more comfortable with, but I wanted to show you both ways. So look at P is pressure, V is volume, N is moles, R is the gas law constant, and T is temperature. Let's rearrange and solve for moles, because that's what I'm missing down here for molar mass. I have the grams, I need to divide by the moles, and I don't know the moles yet. So algebraically rearranged, it's PV divided by RT is N, right? I just divided both sides by RT to get moles by itself. Okay, so now we plug everything in. The pressure was, oops, I don't remember what the pressure was. 107 kilopascals. 107, oops. And the volume, remember they gave you in milliliters. You cannot leave it in milliliters. 148 milliliters, and there's 1,000 milliliters in a liter, so 0.148 liters divided by the gas law constant, which was 8.314 liter times kilopascal over mole times Kelvin. And then the temperature in Kelvin was 286 Kelvin. So let's look at units. Kilopascals on the top, on the bottom, liters on the top, on the bottom, Kelvin on the top, on the bottom. I'm left with moles, which is what I'm solving for right now. So in my calculator, to avoid issues with like parentheses and stuff, I take 107, I multiply it by 0.148, excuse me, and then I divide by 8.314, and then I hit my divide button again, 286, and my moles come out to be 0.00665 something something something. It's a lot of numbers. I'm not gonna write them all out, but you want to keep them all in your calculator. And so you take the 0.290 grams and divide by that many moles, because that's what our moles are. It's 5993. So let's see. And look, you end up 0.290 divided by 0.006655593, whatever it is, equals 43.5 grams per mole, which is exactly what we got doing it the other way. So again, both ways are acceptable. All right. Okay, so we're going to do one more molar mass problem, and that's what I'm going to finish with today. I'm not going to get to density today. So I am going to put up a homework worksheet that has molar mass and density on it, but you only need to do the molar mass problems. I'm going to move to tonight's worksheet. You only need to do the molar mass problems on it. Do not do the density ones because I haven't shown you how to do it yet. Okay, so the next practice problem we will do is this. I give you a 3-liter sample, so I have a volume, and it's collected at 0.901 atmosphere, so this is a pressure, and I gave you at a certain temperature, T, and then I give you mass, so mass is M, right? All right, what is the molar mass of the gas? So again, there are 2 ways to do this. I'll go through both ways, and then we will be finished for today. Yeah, so 42.6 is probably a calculator error. It might be if you round that moles too much, it'll mess up your molar mass a little bit. You want to try to keep the whole number for the moles in your calculator. So let's try this. Start all over. So again, you don't have to memorize these equations. You just have to know how to use them. So we have PV equals nRT. And then we also know that moles equals mass over molar mass. Again, these will be given on a test. You don't need to memorize them. You just need to know how to use them. So the first way that I can solve this is by taking this term and replacing it for moles. Put it in for that guy's moles. So now I have PV equals mass over molar mass RT. Okay, I'm going to rearrange and solve for molar mass. So I'm going to multiply both sides by molar mass to get it out of the denominator. I'm going to divide by PV to get the molar mass by itself. Okay, and then now at this point, it's just plug and chug. So you take all your numbers. So let's see, it's 1.45 grams. That's my mass. 1.45 grams. So mass times the R constant. Now this R constant is going to be based on atmospheres because that's how the R constant changes, is it changes by atmospheres. And if you go look back, again, you don't have to memorize the constants either. You just have to know how to use them. This is the R constant that belongs to atmospheres, 0.0821. And temperature, T, needs to be in Kelvin. So how do you get Kelvin? You take the Celsius and you add 273. So what does that equal? 27. Ooh. Is that 300 exactly? Divided by pressure is 0.901 atmospheres. And the volume was in liters, so that's good. I don't have to do any conversion. 0.3 liters. So let's look at units. Atmosphere, cancel. Liter, cancel. Kelvin, cancel. Grams divided by moles is molar mass. So take a moment to calculate that out. I think I have the answer on the slide. Again, I would multiply all this stuff on the top, and then I would hit divide 0.901, and then I'd hit divide again by 0.3. So I'll give you a second to calculate that out. So we end up with 132 grams divided by mole, gram per mole. Actually, I guess I should have cleared it first. All right, so that's one way to do this problem. So again, I'm going to write it up here so we remember that it was this number. The other way to do this problem is to recognize, okay, I'm dealing with a gas, so the ideal gas law will be helpful. And I'm trying to find molar mass. Well, molar mass is defined as grams per mole. Mass over mole. Grams per mole. So if I have grams and I have moles, I can take grams and divide by moles. Well, I do have grams. I gave you the number of 1.45 grams. So I have grams, but what I don't have is moles. Now the nice thing is Pervner can give us moles. This is moles, this little n. So PV divided by RT is moles. So P is the pressure, so it's 0.901 atmospheres. The volume is 0.300 liters. The R is 0.0821. This is a constant. And the T is temperature in Kelvin, which was 300, I think, right? Kelvin. It's 27 plus 273. That's how you get it to Kelvin. Atmospheres cancel, liter cancel, Kelvin cancel. We're left with moles. So let's get this moles. I'll change the color. So 0.901 times 0.3 divided by 0.0821 divided by 300. The moles come out to be approximately 0.010974 something something something. So that's the number that has to go right here for the moles. So 0.010974. All right, so you take 1.45 and you divide by that number, 0.0109 whatever, and you get the same exact number, which is 132 grams divided by moles.